Okay, in this video, what we want to do is we want to complete this square here. So most times when you're completing the square, it's way easier to make sure that the coefficient of the square of x is 1. So with that said, what I'm going to do is I'm going to divide throughout by 3 so that the coefficient of x is 1. So my first step is I'm going to divide throughout by 3. And so what we're looking at here is x squared plus 2x, and we're going to minus 8/3. So what we do in this case is that we're going to isolate this 8/3, push it aside, and then we're going to deal with the x's first. So we're going to take this part here and we're going to leave a space here. We're going to put it somewhere out here. Okay, now this space that is left here, I'm going to introduce this same space there, and whatever I do here in terms of whatever I add here, I'm going to have to take it from that because we're not going to change the whole thing. So let's see, we're going to focus on this to make it a perfect square. So in making this a perfect square, we're going to take half the coefficient off this term right here, which is the b term here. So half of this is 1. So we're going to have 1 square right there. So we're going to be adding 1 square to make that in a perfect square. Because we added 1 square here, we have to subtract 1 square from this part so that the whole thing still remains the same. Now, because this is now a perfect square, take a look. It's x squared plus 2x plus 1. And you know that this is a perfect square because if you have this, if you have the middle term here, which is 2, and square it, you're going to get this term here, which means that this is a perfect square. So how do we factorize a perfect square? X will be here. Half of this term comes here, plus 1. So if we should quickly expand this, you realize you're going to get this back, which means that this is the factor form for this. So what we're going to do now in the end is that we're going to just work out that fraction to see what comes here. So let us just work this out. So what we do have here is, but I'm going to change that 1 over 1 using a denominator of 3. So it's going to become 3 over 3. Okay? So this is the same as 3 over 3 because I want to have the same denominator so that I could easily work my fraction, and I'm going to get here, I'm going to get negative 11 over 3. So this gives me negative 11 over 3. Remember though, in the beginning, we had actually divided throughout by 3, which means at the end, to make everything balanced and the same, we're going to multiply throughout by 3. So now I'm going to reverse what I did in the beginning. So I'm going to multiply this term by 3, and I'm also going to multiply this term by 3. Now you could see here that 3 would cancel itself one time. So the final response in terms of the completing of the square is 3, open bracket, x plus 1 all squared minus 11. And this is our completed square. What this is suggesting that from this, I'm able to tell what my axis of symmetry is. My axis of symmetry is to equate this part to 0. So when you complete the square, if I want to know the axis of symmetry, I'm going to say, okay, x plus 1 is equal to 0, which means if I solve for x by subtracting 1 from both sides, x is equal to negative 1. My axis of symmetry is actually where x is equal to negative 1. So this is the line that will cut the curve into 2 equal pieces. Now, what is this negative 11 here? This negative 11 is referring to, this is going to be my minimum point, right? Because this point here, this number here only speaks to the maximum or the minimum. And in this case, because my a value is positive, I'm going to have a curve that looks like this. It smiles like this. So this number here, negative 11, is my lowest point on this curve. So what would have been the coordinate of that point? It's going to be right here. So this is where the negative 1 is, and this is where the negative 11 is. So negative 1 and 11, negative 11 would have been the coordinate for this vertex right here of this curve that we're looking at. There we go. Thank you for watching DellyMaths Concepts. And if you like this video, please share, subscribe, and leave a comment. See you next time.